Okay, so this video is about projectile motion, and projectile motion is simply kinematics in two dimensions. It's in two dimensions because we deal with the x direction and the y direction. Since this is kinematics, you need to know the kinematic equations, which I've written down. Okay, the kinematic equations can be used either in the x direction or in the y direction. If they're used in the x direction, make sure you have an x here so you don't get confused. And if they're in the y direction, this would be a y instead of an x. Okay, so this would be a y and this would be a y. V stands for velocity. This little zero here is the initial. Okay, so this is v naught in the x direction, or the initial velocity, and this one here is the final velocity. The a is acceleration. In this case, it's acceleration in the x direction, and the time. Okay, so it's pretty much the same thing for the others. So make sure you pause this video, write these equations down, because you need them to solve every type of projectile motion problem. So I'm just going to go ahead into a problem, and as we do the problem, I'm going to show you what projectile motion is. Okay, so in this problem we have a football. Okay, the football's over here, and the football's being kicked and it's traveling along this path. Another word for path is trajectory. Okay, so this blue line represents the path or the trajectory of the football. So that's your new vocabulary word, trajectory. And the next word that you need to know is what a projectile is, because this unit is on projectile motion. So a projectile is simply anything that is given an initial velocity. So in this case, the football is the projectile because it's given an initial velocity when the football is kicked. Okay, let's read the problem. It says a football is hit with an initial speed of 37 meters per second at an initial angle of 51.3 degrees. So this is the initial velocity of the football. So therefore the football is the projectile traveling at this parabolic trajectory. Assume air resistance is negligible and no other force is acting on the ball. Okay, so let's go ahead and start solving this problem. But before we do that, make sure you know the steps to solving pretty much any physics problem. So the first thing you want to do is assign the direction. Okay, so I did it over here. I'm going to say that up is positive and down is negative. I'm going to say that anything to the right is positive and anything to the left is negative. These are the standard directions in the Cartesian plane. So that's the first thing you want to do, assign your direction. The next thing you want to do in solving a physics problem is to draw a picture, and I already drew it for you. Okay, but pretty much I drew the y-axis here going up, the x-axis going to the right, and I drew the football traveling along this this trajectory. Okay, so this is the path that the football takes. I wrote 51.3 degrees. That's the angle above the horizontal that the football is being kicked, and the initial velocity of the football is 37 meters per second. Okay, now to solve this type of problem, you need to know that the first thing you do is to find the components. Okay, so I'm giving you the initial velocity and you need to find the components in the x direction and the y direction. Okay, but before we do that, let's continue on with this. So we went over the draw picture step. The third step is to write the givens. Okay, so the givens are over here. Okay, and whenever you deal with projectile motion, you have to write the givens in the x and the y, because projectile motions are solved in two steps. Okay, one is the x and the other one is the y, because it's two-dimension. The ball, when the ball travels from the left to the right, is traveling in the x direction, and when the ball is going from going up to going down, it's traveling in the y direction. So this problem is a lot more complicated than the other problems that I gave you, which are in one dimension. So let's take a look at the givens, which I've written, and from this problem they don't really give you a lot of givens, but you can interpret some of them. For example, you know that the acceleration in the x direction is 0. Okay, in every projectile motion problem, the acceleration in the x direction is going to be 0 always, because the football is not accelerating in the x direction. The football is only accelerating in the y direction. The acceleration in the y direction is the acceleration due to gravity. Gravity is bringing down the football towards the floor. So the acceleration due to gravity is negative 9.8 meters per second squared. Okay. The next given is actually this one down here, where it says x initial is equal to 0 meters. In other words, the football is being kicked from an initial distance of 0, and it's going to travel to a final distance which we don't know what it is. That's why I put a question mark there. So this is a given. The initial distance is 0. Now in the y direction, we know also that the initial direction in the y is also 0 because the ball starts from the floor. Okay, this is not always going to be 0. In this case it is, and in this problem the x is 0. In other problems maybe it's not. Okay, but in this case it is 0. Okay, so the next thing you want to do is to write the kinematic equations and solve the problem. Alright, so let's do that. Now I had said a few minutes ago that whenever you're dealing with projectile motion, you need to find the x and y component. Okay, so find the x and y component. Now let's see what we have. We want to find the velocity in the x direction. Okay. Now what do we have? We have the initial velocity. Let's go up here. We're given the initial velocity, and we're trying to figure out the velocity in the x direction. So to find that, we need to use cosine. Cosine is equal to the adjacent. Okay, let me erase this and actually start again so you can see what I mean. Okay, cosine of theta is equal to the adjacent over the hypotenuse. Okay, the hypotenuse in this case is the initial velocity that's given. So the hypotenuse is 37 meters per second. Okay, so the cosine, the angle is 53.1. The adjacent is the x, and the hypotenuse we said was 37 meters per second is the hypotenuse. So to find x, I'm going to bring 37 over this side. 37 cosine of 53.1 degrees is equal to x. Okay, so this is what we need to find the x component. And to find the y component, we're going to use sine of theta is equal to opposite over hypotenuse. One more, again, the angle is 53.1. The opposite side, in this case it's the y, and the hypotenuse is the 37 meters per second, which is the initial velocity of the ball. So now I'm going to bring 37 to the other side. It's going to be 37 sine of 53.1 degrees is equal to y. So this is what we need to find the x component of the velocity and to find the y component of the velocity. So now I'm going to pull out a calculator and see what we make sure the calculator is in degree modes. Okay, so if it's not in degree modes, then you're going to get the wrong answer. Okay, so let's put in 37 cosine of 53.1, and you get 22.2. And for the other one, let's put 37 sine of 53.1, and we get 29.58. Okay, so what I just did was find the x component. So I found the velocity, the initial velocity in the x component is equal to 22.2 meters per second. And I found the initial velocity in the y direction, which is equal to 29.6 meters per second. Okay, so this is the first thing that you need to do to solve any projectile motion problem. You need to find the initial velocity in the x direction, and you need to find the initial velocity in the y direction. Okay, you need to find the components. Now I'm running out of time, so in the next video I'm going to continue this problem.